Hello, Mahesh. So I'm going to start a technical snap for BPCL interview, and you have to strengthen the material for today's snap. Correct?
Yes, sir.
So, first of all, tell me what is stress?
Uh, so stress is the resistance force developed due to external force applied on your body.
And what is the difference between stress and pressure?
So stress and
Pressure.
uh, sir, pressure is not it is a property of the fluid. It is pressure is there. There will be only pressure force, sir, but whereas in stress due to force it is developed. Whereas pressure force is developed due to pressure.
Hmm.
Uh, yes, sir. There is a
Any other
difference,
difference?
sir. Any other
Any other
difference?
difference?
Sir, in stress, when we decrease the area, there will be more stress developed. Whereas in pressure, even if you decrease the area, the pressure won't be decrease itself. Pressure will be increased only.
Hmm.
Yes, sir.
Okay, so tell me, stress comes first or strain?
Strain will be first, I think, sir. They both are complementary to each other, but uh,
Hmm.
due to elongation only, there will be for internal resistance force developed. So I
Hmm.
think strain comes first.
Strain comes first.
Yes, sir.
Okay. Okay, so what do you mean by resilience?
So resilience, uh, body tends to come to its original state even after elongation. The more the resilience, the easier the material to get it to original state. That is how we say how a material is resilient. Uh, yes, sir.
Okay. And what do you mean by resilient material?
Sir, if you take a spring, if you elongate it, it will come to its original length. Then we say it is a resilient material. Like it has more resilient. It is more resilient material.
Hmm.
Yes, sir. Without deformation.
Okay.
Yes.
And where it can be used?
Yes. Um, sir, I don't know any examples. Sir. Springs are one of the examples. Sir. Mostly springs
Spring.
should be
Okay.
resilient materials.
Okay. And what is brittleness?
Becomes so brittleness when a material is when we apply tensile forces, it will break without any deformation. So then we say it is more brittle. That is how it is defined. Without any deformation, it will start. It will break. So that is how brittleness.
Hmm. Okay. And what do you mean by hardenability?
Sir, a material resists to penetration or any scratch or any which is more resistant to penetration, sir. That we call it is hardenability.
And what is hardness?
Hardenability. Sorry, sir. This is the definition for hardness, I think. I don't know about
Mm,
hardenability.
okay. Okay, so let's suppose you have a bar which is subjected to an axial load, correct?
Okay, sir.
So, and let's assume if it is a brittle metal, then tell me the failure plane, from which plane it get failed.
If theta equal to 0, it will be plane. The plane will be at 0 degrees, it will fail, sir.
Hmm.
Yes.
Okay, and let's suppose if it is subjected to pure torsion, then and the metal is remain brittle.
Material remaining metal, pure torsion. Sir, it will fail at 45 degrees to the plane of application of force. So 45 degrees theta equals. Hello, sir. Hello, sir. Am I
Yes,
audible?
yes, tell me.
Sir, when theta equals to 45 degrees, it will fail, sir. At a plane, theta equals to 45 degrees.
Okay. Okay, and what do you mean by a prop cantilever beam?
Sir, which beam, sir?
Prop cantilever beam.
Continue. Sir, I don't know exactly.
Okay. And what do you mean by section modulus?
Sir, it is a ratio of moment of inertia to the y max from neutral axis to how much distance to the surface, that is y max ratio of moment of inertia to y max.
Hmm. And for safe design of beam, what about
Sir,
section modulus? For safe design of beam, the section modulus should be low or high.
sir should be high, sir.
It should be high.
Yes, sir. Section modulus should be high.
And what do you mean by beam of uniform strength?
Beam of uniform strength.
Hmm.
Sir, the strength toward the beam should be same. Like wherever we apply force, the variation of stress strain should be same. That will be named
Hmm.
as strength.
And
Uniform
how we
beams.
can achieve? Let's suppose you have a cantilever beam which is subjected to a point load at its free end.
Okay, sir.
Hmm. Then how you can achieve? How you can make these beams in such a way that it is subjected to a uniform strength throughout the length?
Sir, while bending, it should be at same radius, like circular radius. Uh,
No.
no, sir. Uniform strength. Um, sir, I don't know, sir.
Okay. And what is column?
Sir, the area of cross section and to the ratio of area of cross section to the length of the beam should be comparable, sir. That can be named as column. There are three types of columns: large, small, and medium columns.
Okay. And let's suppose you have a cantilever beam, and at mid-span, if you subjected to a constant moment, correct?
Okay,
Then
sir.
can you tell me how much deflection takes place at free end?
Sir, there will be no deflection at the free end, I think.
No deflection.
I don't remember the formula, sir, but there is no momentum is coming in the deflection formula.
Hmm. Okay, and let's suppose you have a shaft and it is subjected to pure torsion at mid-span. Then how much angle of twist we get at the free end?
Sir, formula पता नहीं sir. I
Hmm.
don't.
Okay, Mahesh, so now I'm going to conclude your interview. So Mahesh, we have one marathon session,
Okay, sir.
correct?
Yes, sir.
In Engineers Career Point YouTube channel.
Yes, sir.
You write down Engineers Career Point YouTube channel,
Engineer's career point.
or you just say hi to me so that I can share the link, correct? So you
Okay,
just
sir.
watch that lecture, that is very important for you. And if you watch the whole lecture, it is actually a 6 hours lecture in which
Okay,
I
sir.
cover entire strength of material with detailed formula also,
Okay,
correct?
sir. Okay, sir.
So everything get revised if you read, if you watch that lecture, correct?
Okay, sir.
And right now you are able to give some questions, but when I ask some technical question, when I ask some
Formula
uh,
always.
formula based question, then you stuck, correct?
Yes, sir.
So you just watch once again, and after 2 to 3 days, you give your another snap,
Okay, sir.
correct?
Yes, sir. Sir,
Okay, so
its
yes, tell me.
failure theories of failures are also covered in that video, sir.
Yes, yes,
Okay,
entire
sir.
strength of material.
Okay, sir.
Okay, so all the best.
Okay, sir. Thank you.